Good afternoon, everyone. For today's video, I'm going to explain to you everything that I know about a condensing unit. Now, before I begin, I have to ensure that I have my safety glasses. I'm in proper safety wear, and the most important step to ensure that our disconnect is off. Now I went a step further. The disconnect is out, the wires are disconnected, and the breaker inside is also in the off position. So we're safe to continue with this demonstration. Now what we have here is a 2-ton unit. That 24 represents the 2-ton unit, and this unit was manufactured in May of 2016. Now, just by looking at the unit, we can already identify some components. If you look carefully, that is our condenser fan motor. Those are the blades. If you look through, we'll see that is our scroll compressor, and the condenser coil surrounds the unit. Let's now move to the electrical compartment. Now this compartment is held in by one 1/4" drive screw. We'll take our Klein nut driver and remove the screw. Now careful not to lose your screws. A lot of times we come across units with missing screws. We put that to the side. We're going to remove the cover. First thing we can check for is that we have our ground. Our ground connection is here, our green wire, so our unit is properly grounded. Let's identify some of the components. Right here we have our double pole contactor for high voltage. We have our dual run capacitor that controls our condenser fan motor and also our scroll compressor. We have our low voltage winding that supplies our 24 volts AC low voltage to energize our contactor. Now, even though we have already established that the breaker is off and the disconnect is also off, we should also always check our voltages. So we go across our contactor, we read 0 volts AC, go across both legs, 0 volts AC, go to ground, 0, go to ground, 0. It's also good to check our low voltage, go across our coil, 0 volts also. Now I'm going to bring you through a sequence of operation. Now these wires, the red and the white, they're coming from a thermostat. When our thermostat sends the 24 volts across these two wires and the coil becomes energized, it pulls in the contacts, and we have our supply voltage, whether it be 230 volts, 208, and this sends voltage to our condenser motor and also to our scroll compressor on the inside. Now that we are on the outside, we can also identify our refrigerant lines. Your smaller line will be your high side, your liquid line, and your insulated line, which is of a larger diameter, will be your suction line. So these are the ports where you connect your gauges when you're testing your pressure, when you're charging a unit, when you're pulling a vacuum, etc. If we follow our liquid line, you can see we come to our first component, which is our liquid line filter dryer, and right after that we have our side glass, our liquid line side glass. These These are not common on most residential units, but for this application we have a sight glass that shows our subcool liquid that is going to our inside air handler unit. Now our condenser fan motor is usually held in by 4 screws. I already removed them, so we can just lift this and we put it to the side. Now this is your condenser fan motor. These are the blades. It freely spins, so we have pretty good bearings inside. If you look inside, this is our scroll compressor, 240 volt scroll compressor. These are your plugs. This is your plug. These wires come from both your capacitor and also from your contactor. If we look closer to the inside, we have our condenser coil. Now we have hot superheated vapor that leaves the compressor, goes to our condenser coil. While the fan spins, it pulls in cold ambient air through the sides and vents the hot air through the top. The refrigerant flows through the coil, condenses, and then it comes out on the liquid line and continues to your evaporator coil. For this particular condensing unit, the wires to our compressor are purple, black, and red. These might vary per unit manufacturer design, but these are common colors that you'll see going to your compressor. For the condenser fan motor, you'll have your orange, your brown, and your black. These are also very common wires that are seen on residential units that supply your 240 volts to energize your condenser fan motor. For proper preventative maintenance, you want to ensure that your condenser coil is maintained clean. So if you come to your unit and leaves are inside, try to remove the leaves. Your coil, you can wash them with tap water. Don't use too much pressure because you might damage the coils, and that will have your condenser coil lasting a lot longer. You have a more efficient unit and you will have no issue with cooling unless there is another system component breakdown. Now I'll discuss some of the common failures that might occur on your outside condensing unit. The compressor is probably the most expensive part to replace, and a lot of times it is misdiagnosed. In our compressor, you have your start winding, you have your run winding, and you have your common terminal. You also have what is called an internal overload, which is a thermal overload that opens the circuit if your compressor runs too hot. A lot of technicians or persons that work on HVAC will come to a unit, and when the resistance readings are off, they automatically assume that the compressor is bad. Most of the times that is not the issue. Sometimes it is not running due to an open thermal overload. So you as a technician need to just run some tap water over the compressor for a couple of minutes until the temperature gets down, and then you resume your test, and 95% of the time you will get correct readings if it was off and overload. Another common failure point is your condenser fan motor. Most times you might have bearing failure, you might have a burnt motor which requires replacing it. You can decide to go with an OEM replacement, but the customers usually prefer an aftermarket replacement, which is a bit less expensive than an OEM motor. You also need to be extra careful with the blades. They're easily damaged, and if bent out of shape, it is almost impossible to get them back in shape. So be very cautious when you're messing around with your condenser fan motor fan blades. Now back to our electrical components. Another common failure point is your contactor. To properly diagnose your contactor, you need to verify that your coil winding is not burnt, your coil winding is not open, and ensure that you don't have pitting on your contactor terminal points. So for common preventative maintenance, you might want to check that your contactor is in good working condition. If possible, you should always try to mount your capacitor in the upright position, which is the opposite of this, so that the oil is not saturated at your terminal connection points. Apart from that, I think I covered, all of the failure that can or might occur on your condensing unit. Occasionally you will have a leak in your condenser coil, but that is rarely seen on these units. So that sums up my review of your outside condensing unit. Please remember to share, like, subscribe, and comment what you'd like to see in future videos. And thank you for watching.